and welcome in, my party people. Welcome into our class here where we're going to get started on polynomial distribution. So today's game plan, everybody, is really going to first come off to understanding how to multiply terms. I'm sure we all have seen or can recognize polynomial distribution, but we're really going to be focusing on those little reasons why. So first, how to multiply terms. Number two, combining like terms where we need to. That way we can then build that confidence through that timed practice. That's how it's going to go, my party people. So with that said, let's just go ahead and dive on in. First things first, let's take these notes down. So when it comes to multiplying terms, everybody, here are the two things that we must always take into consideration. Number one, we're going to multiply the coefficients, and I'm going to really I'm going to help you understand and remind you of what a coefficient is. But for now, write that down. And then number two, when you are multiplying terms, you will add the exponents of the same variable. So my party people, what I want you to do now is go ahead, take a moment, write this down, and then I'm going to give us plenty of examples to work with in this area. That way we can really wrap our heads around this. All right, so let's go ahead and again, continue understanding this idea of multiplying terms. So first things first, everybody, let me go ahead and show you your first example. Right over here, let's zoom on in. And let's say we're discussing multiplying the following terms. Let's say we're going to multiply 5 times, let's say 2x. Now, everybody, quick question. Even though there is no x over here on the 5, even though there's no x on it, can we still multiply? Correct. The answer is going to be yes. The answer is going to be yes. But let me go ahead and kind of juxtapose this on something else. Who here has heard that when we are doing this, let's say adding, who understands that we can't add these together? Who understands that you cannot add these together, but you can for sure multiply them? Give me a me or a yes. Denisha, I love how you said in the chat box that, yeah, these are not like terms, so you cannot add them. You can multiply any type of terms, for sure. You can multiply any type of terms. But when you're adding or subtracting, what you're saying is, hey, I'm going to add or subtract the same things, the same amounts, in which there's no x in front of the 5. So you're saying 5 plus 2 of these x's. Well, that's the same thing as saying 5 plus 2 of these x's. You can't combine these. However, if we were to say 5x plus 2x, well, now you're saying 5 of these x's plus 2 of these x's, that's going to equal 7 of those x's. My party people, does that make a little more sense before I take our attention back over to multiplication? Just wanted to really overview on that difference between multiplying and adding terms. Cool, sounds good. And don't worry, the next slide, we're going to have plenty of chances to really hone that in. But for now, let me go ahead and just take that, make it slightly smaller, throw it to the corner, and let's understand what we're going to do here. So let's take a look at our notes here. We're going to multiply the coefficients. Well, a good question might be, Coach, what the heck is a coefficient? So what a coefficient is literally just the number that's by itself or in front of the x. That's it. That's what a coefficient is. So in this case, everybody, help me out. What is 5 times 2? Yeah, I think that's a disrespectful question almost, right? That's going to be 10. So we have 10, and then we are going to multiply the variables. Well, here's a common mistake that a lot of folks might make. Even though we don't see an x here, again, the wrong way to do this is to say, oh, well, there's no x there, so that must be a 0, and that x's must cancel out. Not quite true. If only one of the terms has a variable, no worries, just bring the variable with you. Just bring the variable with you, that's it. So you're going to go ahead and multiply those coefficients, the numbers that are in front of the x, those whole numbers, multiply them together. 5 times 2 is 10. We had an x here, but nothing there. No worries, just bring the x over. Now I want to show you a separate example here. I want to show you something else. Let's go ahead and change the color here. Let's draw a little barrier. And let's say we have something to the effect of 3x squared multiplied by, let's say, 6x to the power of 3. Let's try something on the opposite end of the spectrum here. So everybody, let's follow the same exact rules that we just wrote down. Number one, just like we said, we're going to multiply those coefficients. Everybody, which one is the coefficient for 3x squared? Is it the 3 or is it the 2? Which one is the coefficient? Yeah, 3 is that coefficient. Excellent. Thank you. Same thing over here with the 6x cubed. The 6 is the coefficient. So again, we're going to multiply those two together. Everybody, 3 times 6. That's going to give us what? Yep, that's going to give us 18. So let's write that down. Nice and easy. And then let's take a look at the variables. Everybody, remember, we are going to add the exponents of the same variable. Again, this is when we are multiplying terms. We are clearly multiplying terms. Everybody, are these two variables the same letter? Yeah, they are absolutely the same letter. And so what did we say? We would add their, what's that E word that I'm going to cover up that you can't see? I said we're going to add those what? Yeah, we're going to add those exponents. So here's what we have. We're going to have 18x to the power of 2 plus 3, which is going to be 5. And there we are. Now, you might be sitting here writing this down thinking, oh yeah, coach, yeah, this makes a lot of sense. I know exactly what I'm doing. But is anybody here looking at this thinking, why do we actually add these exponents? Is anybody wondering that? Even though we are multiplying the terms, where does addition come into play? Why is that even the thing to do? Why should we do that? Okay, good. Let's go ahead and answer that question. It takes less than a minute to answer this. Everybody, let's go ahead and just take a quick little, kick it back to God knows how long, depending on your age in this class. But my party people, can you remind me, what does x squared actually mean? Like, it doesn't even have to be x. It could be 3 squared, it could be 5 squared. What does an exponent of 2 actually mean? To the power of 2, that's absolutely correct, but there's a more specific way to think about it. Exactly, yes, I love that in the chat box there. X squared means x times x twice. 3 squared means 3 times itself twice. When we take a look at 5 squared, that is 5 times itself twice. Again, it's really dependent on the exponent. The exponent tells you how many times you're multiplying that number. So that's part one of getting to how we magically get this 5. So let me go ahead and take this here and just move it down and continue the conversation here by extending it from x squared to x cubed. Everybody, if x squared means multiply x by itself twice, what does x to the power of 3 mean? Okay, yeah, that's going to be x multiplied by itself 3 times. Absolutely, let's write that down. So right here, that'll be x multiplied by itself 3 times. Okay, now let me ask this next question here. Before my voice cracks, let me ask this next question here. Let me not give you the left side. Let me give you the right side. Let me give you the right side. Everybody, what number am I going to write down on the exponent when I have, let's say, x multiplied by itself that many times? What number am I writing in the exponent? Yeah, that's going to be 4 because we are doing 1, 2, 3, 4 x's multiplied together. And so that's represented as, again, in a short form way, in a shorthanded way, that is x to the power of 4. So everybody, that was a nice little detour to get us right back to this. Let me go ahead and show you. So let me pull this down right over here and let me show you what's going on. Everybody, 3 times 6, that's still going to be 18. I don't think we need to argue that, right? But what I will argue is, right over here, let me use 2 different colors to highlight what we see. Let me take this out and let me use red and blue. For x squared, my party people, how many times when I want to separate it, when I want to write it like this, not like this, when I want to take the x squared and just write it x times itself a number of times, how many x's am I going to write for x squared? Yeah, I'm going to write 2 of those x's. So I'm going to write right over here, I'm going to write x times x. Now, some of you might be privy to what I'm about to do next, but that's good. That's a good thing. Let's take a look over here. Let me actually let's use blue. Let's take a look at the x cubed. Everybody, x to the power of 3, how many x's am I writing there? Oh, cool. Looks like we all understand that. That's going to be 3 of those x's. Okay. So let me take that and write x times x times x. So everybody, remember this. Because we are multiplying, check that out right there. Because we are multiplying these two terms together, we are multiplying those variables together. We had 2 of those x's here, multiplied with 3 more x's here. Everybody, quick question. You tell me, how many x's do we see multiplied all together? How many x's do we see multiplied all together? Yeah, that's going to be 5 total x's multiplied together. And so with that said, my party people, guess what? Since we have 5 x's together, that's going to shorthand form into x to the power of 5. So I know that was a pretty long-winded response, long-winded explanation, but my party people, does it make sense why we add those exponents when we are multiplying variables of the same kind? I have 2 x's here, 3 x's there. If I multiply all of them together, that is 5 x's multiplied back to back. The coefficients, the 3 and the 6 in front, 3 times 6, that becomes 18. That's straightforward as it comes. It's the variables I want you to pay attention to. When you are multiplying variables of the same letter, you will add those exponents. That's it. That's all you got to worry about. That's the shorthand way of thinking about it. When you are multiplying variables of the same letter, just add those exponents. So let me zoom on out a little bit. Let me zoom out just a little bit. But we will definitely be going over the adding like terms rule and multiplying powers and exponents of the same base. So with that said, everybody, how are we feeling so far when we have the same variable? Good, and no worries. Even if you're not feeling the most confident in the world, I mean, class literally just started less than 10 minutes ago, so no worries at all. I'm not here expecting perfection. I'm just expecting the introduction. And then allow me to do my thing as we keep practicing. We got this. So the last thing I'll answer before we move forward here to the next part of our conversation, the last thing that I'll answer here is, well, what if we're multiplying different letters? Which is very possible. When we are multiplying variables or terms that have different letters or different variables, here's what's going to happen. Here's what's going to happen. Let's say I'm multiplying x times y. Well, guess what? That's x times y. If we are multiplying, let's say 7 times x, well, that's just going to be 7x. Whenever we are multiplying variables or terms that don't have the same base, we just write them as multiplied together, and that's it. If I were to do, let's say, 2x multiplied by 4y to the power of 5, although this looks kind of ugly, although this looks kind of intimidating, it's still the same deal. All we're going to do is follow our rules and say, hey, let's multiply those coefficients. Again, those numbers in front, we'll multiply those always. So that'll be 8. But everybody, can we multiply x and y to the power of 5? Not quite, right? We can't actually mix them together, but we can just go ahead and just say x, y to the power of 5. This exponent here does not go to the x. It stays on the y. It stays exactly where it was to begin with. So everybody, with that said, are we ready to move forward here to the part of adding like terms? Perfect. Sounds good. So let's go ahead here and move forward to the next part, the next very important part about combining like terms. So I want you to go ahead and begin first by writing this down. When it comes to adding like terms, this can only be done when we have the same letters and exponents on each of the terms. Be very careful writing this down. The same letter and the same exponent on those same letters. So just like previously, we'll take a moment here. We're going to go ahead and write these notes down, and then we'll proceed momentarily. All right, so let's recap real quick. So again, when we're adding like terms, We can only add these like terms when we have the same letter and exponent. So let me give you a couple of good examples and another couple of bad examples. That way we can really understand the difference. So zooming on in over here, here's a good example. Let's go ahead and just put a green check over this. So a good example would be right over here. Let's say we have 3x plus 2x. So notice, everybody, we have the same variable, the same letter, x, and we have the same exponent on these x's. Now, I want to go ahead and give a little pop quiz. When we don't see an exponent, what exponent can we assume? Again, when we don't see an exponent, what exponent can we assume? That's correct. That's going to be 1. That's going to be a 1. So if you don't see the exponent, again, assume it's 1. So in this case, everybody, do we have the same letter? Yes. Do we have the same exponent? Yes. So we can add these together. Here's how you add like terms. We will add the coefficients. Everybody, 3 plus 2 gives us 5. So we'll write out the 5. But here's the difference between adding like terms and multiplying terms. The variable, you keep it the same. Because when you're adding, you're saying, hey, we have 3 of this thing plus 2 of the same thing. That means we're going to have 5 of that thing. Not 5x squared. This is a very common mistake. No, we are not going to write a squared at the top of that. We are basically saying we have 3x's plus 2x's. That's just 5x's. That's just 5 of those x's. When it comes to multiplying, absolutely we will be adding those exponents that exist. But when it comes to adding like terms, no. When you know that they're like terms, you just add those coefficients, those numbers in front, and you do no other work. You keep the variable the same as it was. My party people, before I continue, does that make a little more sense than it did before, or does it help reinforce those hunches you had? Perfect. Right on. So let's keep going with the examples, showing good examples, bad examples, just to make sure that we can avoid some common mistakes. So here's a bad example over here on the right side. A bad example would be, let's say we had 3x plus, let's say, x squared. Some folks might be inclined to say, okay, well, even though I don't see a number in front of the x, in front, not the exponent, even though I don't see a number in front of the x, what number is always going to be there? Yeah, it's always going to be a 1. Some folks might believe that, hey, I got the 3 and the 1 in front of it. I'll add that and I'll get 4. And then I'll just write 4x squared. Or they might even write 4x cubed. No, that's going to be wrong. That's going to be wrong. Again, notice, everybody, quick question. Yes or no, do we have the same variable? Do we have the same letter? Specifically, the letter. Do we have the same letter between these two? Yes, we do. So then you might be asking, well, coach, what's the problem? Well, look at the rule again. You can only add like terms when you have the same letter, variable, and the same exponent. Everybody, do we have the same exponent here? No, we do not. No, we do not. So although at face value, if you're rushing yourself, if you're a little anxious in the moment, I know we might believe that we can add these together, but no, even though we have the same letter, we need the same variable or the same exponent on those variables to be able to add it. So with that, let's go ahead and turn our attention over to another good example. Here's a good example. Let's say we're looking at x squared plus x squared. Everybody, again, even though we don't see anything in front of the x, what number is always there? Yeah, it's going to be 1. So in this case, when we add x squared plus x squared, you want to think about it like this. I have 1 of this x squared and I have another of this x squared. How many x squareds do I have? Yep, that's going to be 2. 2 of those x squareds. Again, a fresh reminder, because I know a couple of us are still processing this. I got you. The exponent stays the same. That's why you need the same exponent and the same letters and the same exponents on said letters. Because when you look at this, you're saying, hey, I got 1 of this variable plus another of that same variable, I now have 2 of that variable. And a good way to kind of show this is by using a nice little block. Let me go ahead and take that, give it a fill. I'll go ahead and just make it blue or something like that. So the way that you can think about it is like this. Hey, if I have this box here plus another box there, I am going to have 2 of those boxes. That's one way I can think about it, everybody. You add the coefficients. You have 1 of this box plus another of this box. That means you have added together 2 of these boxes. Very different than multiplication, everybody. Very different than multiplication. Another way that I can put it for you here is like this. Let me go ahead and say something like we have 3y cubed plus 5y cubed. The way I can put this for you, everybody, is like this. We can simply say, let me use a different color. Let's use purple. Okay, it'll just fill into the same one. That's fine. But here we can say, hey, we have 3 of this variable plus 5 of that same variable. Everybody, how many of these variables or boxes are we going to have? If we have 3 of these boxes plus 5 of those boxes, yeah, we're going to have 8 of those boxes. And so we'll write 8 of said boxes. The only difference is we're not calculating with boxes. We're calculating in terms of y cubed. So again, everybody, the letter and the exponent come together. They are the same in terms of how you think about it. When you are adding terms, you need the same letters with the same exponents on those letters. That's the biggest part I can, really distribute here today before I get into the actual main idea. But everybody, in your notes, when it comes to adding like terms, you do not add the exponents. When it comes to adding like terms, you just add the coefficients. You add the numbers in front of those exponents. When is, pop quiz, when is the only time that we actually add exponents? Correct, when we are multiplying. Exactly. When we are multiplying. That's the only time. So I know that that's why I introduced 2 things here when it comes to multiplying and adding, because both come together when it comes to distributing polynomials, which is what we're doing today. So let me go ahead and just read through these questions here real quick. So what happens when the exponents are different? So I'm going to do that example right there, Maravnia. Let's go ahead and go through that example. Let's say we have 5x cubed plus 6x to the power of 5. Let's go ahead and see what's wrong with this. All right, everybody. So if I'm going through this, I'm saying, hey, I have 5 of these x cubed, and I also have 6 of these x to the power of 5. Everybody, is x cubed the same as x to the power of 5? Correct. They are not the same. And because we do not have the same exponent on each of those variables, these are not like terms. These are not like terms. Has anybody here ever noticed how whenever we write something like, hey, x squared minus 3x plus 8, you ever notice why it's written like this and we don't just like add these all together? It's because we can't. It's because we can't. Because this x squared is not the same as an x term, and x is not the same as a constant. These are all different terms. They are not like terms, and so you leave it as is. And that's the same exact thing that'll happen right over here. 5x cubed plus 6x to the 5th, it stays the same. It'll just be written as 5x cubed plus 6x to the 5th. There is no simplification to be done. It just stays as is. So, my party people, do we have those notes down? Are we ready to try and practice a couple of more distribution or multiplications and a couple of more combining and adding like terms? Right on. And even if we're a little confused, here's what I need you to have in your notes, the notes that we took. That's all you need. We're going to get into a couple of practice problems here. Let me create the new page right there. Perfect. So I just created the new page. So now let's go ahead and go through a couple of examples. So number 1, let me make sure I zoom in just a little bit. Okay, cool. Good size. So let's go ahead and say we are doing over here, let's say we have 7x. Let's go ahead and try this out, everybody. So help me out. If I'm looking at this, 7x times 3x squared, can I do this? Yes or no? Is this able to be done? Or should we leave it as is? Okay, y'all are telling me that we can work with this. We can do something with this. Okay, sounds good. What am I supposed to do when I'm multiplying between these two? What am I supposed to do? Right, we are multiplying, so what we're going to do is we are going to multiply the coefficients. Everybody, 7 times 3 is going to give us, yes, 21. And then what did we say, everybody? When it comes to multiplying variables, what do we do with those exponents? Yeah, we add the exponents, because remember, everybody, we're saying we have one of these x's being multiplied. This represents two more. So we have 1, 2, 3 x's being multiplied. X times x times x. Because remember, I'm going to say it one more time here. I got you. X squared is the same as x times x. If we already have an x over here, that's 3 x's being multiplied. And remember, we don't need to write, oh yeah, x times x times. No, we're not here to longhand it. We're here to shorthand it. And so instead of writing the x 3 times, a shorter way to write it is just x to the power of 3. Because that's how many x's are being multiplied together. So my party people, are we good on this one before we try another example out? And again, it'll take time. You're good. Remember to give yourself that patience and grace. Everybody here can do it. Let's go ahead and try this next one out. Let's say we're looking at the following example. Let's say we have, over here, we have 9x multiplied by 4y. Ooh, this one looks a little different. Looks a little scary. Everybody, quick question. Can we multiply x and y together? Not quite, right? They're not going to combine, but at the end of the day, here's what we're going to do. When we are multiplying terms, everybody, do they need to be like terms? No, they don't. When you are multiplying, they do not need to be like terms. If they can be multiplied together, great. If they can't, just write them next to each other. And here's how that's going to look. Those coefficients, we can still multiply those together. I can grab the 9, and I can grab the 4. Everybody, what's 9 times 4 going to give us? 36. That's absolutely correct. Appreciate y'all for that quick response. And then we have the x and y still being multiplied, but there's nothing to do here. So all we're going to do is just write 36 xy. That's it. That is it. We don't need to get fancy here. Don't need to try to get fancy. If you can multiply them together, great. If not, well, they're still being multiplied, just written next to each other, one after the other. Typically, as mathematicians, we recommend alphabetical order, but if you wrote y then x, you're going to see that a lot of the answers are typically written in alphabetical order. So, with that, everybody, I want to go ahead and now take our attention over to 2 more examples with addition and subtraction, so combining like terms. Let's take a look over here. Let's say we have ourselves 3x squared plus 3x. Everybody, what's the answer? Can we add these? Can we add these? Okay, so I see a lot of yeses. I see some no's flowing in. Let's confirm this. Let's use our notes to really back this up. Everybody, to add like terms, or for terms to be like terms, we need the same letters. Everybody, do we see x's on each? Yes, we do. Absolutely. But do we see the same exponents on those letters? Oh, no, we do not. Oh, no, we do not. We have a 2. We have a squared on the x. We have a 1 on this regular x here. These are not like terms. Not like terms. Not like terms. Here's another one. Let's go ahead and say we have 5x cubed plus 4x cubed, everybody. Are these like terms? Oh yes, these are like terms. These are indeed like terms. Here we are going to have x and x. Cool, same variable. And then we see that we have 3 and 3, same exponent. And so with that, yes, we have the same variable and the same exponent. So we can indeed add these together. And how do we add these? Remember, we are adding those coefficients. 5 plus 4, that's going to give us 9. And remember how we read it. We have 5 of this thing plus 4 of these things. Well, that means we have 9 of those, quote, things. 9x cubed. Now, I'm definitely seeing in the chat box some more of those correct answers flowing through, especially from some of us that were a little confused earlier. So is it safe to say that with these subtle warm-ups, we're feeling slightly better in the right direction? Good. Right on. Now, let's go ahead here and take one final note down before we start getting into our practice or torture, whichever way you want to call it. But let's go ahead and take this note down really quick. So here is the main note for today on the distributive property. Let's write this down here. So here's my main notes. So distributive property. So here's our main note. Basically, everything from one parentheses must multiply with everything from the other. So let's write this down like this. So again, I'm going to use red here. Make sure everything from one parentheses multiplies with everything from the other. Right there. All right, my party people, make sure to write that down, as crooked as that looks. But there is the main note that's going to carry us through the rest of today's class. Again, make sure everything from one parentheses multiplies with everything from the other. I'll give you a moment to write that down, and we're going to dive straight into our first program practice problem, and you're going to see how this takes effect. I got your back every step of the way. So let's take it over here to this first example, and the main goal of this example, my party people, is strictly going to be, hey, let's apply the distributive property. Let's apply this the right way. So when we just took those notes down, I want you to take a look at your notes and then answer this question. Fill in the blank. With the distributive property, we are making sure that everything from one parentheses blanks with everything from the other. What did we say? When it comes to the distributive property, we are making sure that everything from one parentheses blank with everything from the other. Chris, appreciate you being first there. Yes, multiplies. We are making sure that everything from one parentheses multiplies with everything from the other. So to really drive the point home, I got y'all, my party people. Let me show you here. So I'm going to use two different colors, starting from this 3x squared. So I'm going to go ahead and draw from the 3x squared to the 2x. That's one of the terms inside the parentheses. But everybody, if I'm going to draw another line, I got to make sure that that 3x squared also multiplies with the what? Got to make sure that the 3x squared not only multiplies with the 2x, but also multiplies with the negative 5. Everybody take a closer look here. That is a negative on that 5. We do not want to put ourselves in a position to ignore a sign or ignore a negative, because I think we all know how fatal that mistake can be on the actual test. So let's go ahead and get into it here. First, we noticed that we are multiplying the 3x squared with the 2x, but you got to make sure that it also multiplies with everything else, the negative 5. So in red, I'm going to mimic this over here, where we have 3x squared multiplied with the 2x that we saw. And then I'm going to bring that negative symbol, I'm going to bring that over with us. I'm going to put minus, and then I'm going to write the 3x squared, and I'm going to show it multiplying with that 5. I put the negative in front just to have it in front, but I'm multiplying with that 5 right there. So before I continue, does the idea that we just wrote down, everything from one parentheses multiplies with everything from the other? Are we visually seeing that happen before our eyes? Sweet. Again, everything from one side of the parentheses multiplies with everything on the other. So 3x squared multiplies with the 2x, booyah. And then we also multiply it with that 5, but it's considered a negative 5, so we just put the minus in front. But notice, boom, there it is. That's what distribution looks like. Now, of course, we have to clean things up and simplify, but that here, right there, is the premise of everything that we're doing today. Here we go. Let's go ahead and figure this out, everybody. So when we have 3x squared times 2x, that's going to be a 5 in the front, right? Nah, that's going to be a no. That's going to be a no. Because remember, everybody, what do we do when it comes to multiplying terms? What do we do with those coefficients? What do we do with those coefficients? We multiply. When we multiply terms, we multiply the coefficients. 3 times 2, that's going to give us 6. So I can tell you right now, it's not going to be that one. It's not going to be the 5. That was a distractor answer. Let's just go ahead and cross that out. So we have the 6 in front. And then everybody question, what do we do with the variables that we multiply? Because I have an x here and an x there. What do we do with those variables? Add the what though? You guys are saying add. But add what? Add the what? Yeah, we're going to add those exponents. Thank you for being specific here. Again, specificity, always going to be a good long-term thing to do. So we are going to take those exponents. We have 2 of those x's here. So 2 x's multiplied with another x, because that's just a 1 there. That's going to give us 3 x's being multiplied back to back. So before I continue, everybody, do we understand how we took this here, 3x squared times 2x, we turned that into 6x cubed? Cool, sounds good. Now let's go ahead and take care of part 2 over here. So that negative, that minus, let's just keep that coming right there. There's the negative. Now let's continue forward here to the 3 on the x squared. The 3 multiplied by the 5. Everybody, what's 3 times 5? Correct, that's going to be 15. Nice and easy. And then everybody, because this is x squared and there is no x over here, what am I supposed to do with the x squared? Do I delete it entirely? Do I modify it? Or do I just bring it down? Yeah, that's right, Denisha. We just bring it down. We just bring it down. We keep it as is. X squared right there. Just like that. So I'll go ahead and underline this one in purple, showing you what we got over here. And I'll underline this next part. I'll do yellow, showing how we got this here. So is there anybody here that was a little anxious before, but are starting to see, how we can actually get this done and get the correct answer in this case, like C? There we go. There's the confidence starting to come in. Good. Good. And again, it's going to take more practice. It's going to take more practice. But remember, everybody, bit by bit, we got this. All right. So with that, let me go ahead and give y'all the opportunity to try another problem out. Who is ready for another one? Perfect. All right, sounds good. Let's go ahead and get into it. All right, so let's take a look at example number 2 here. We're going to multiply the following expressions. So we are going to be multiplying, take a look here, a negative 4x cubed. And that's going to be multiplied with, and notice the parentheses. Notice the parentheses. We're multiplying it by the expression 3x plus 7. Everybody, quick question. What is the word of the day that we are going to be applying right now? Namely, when I take this negative 4x cubed and multiply it by both or each term inside of that expression, what's that D word that we have just finished learning? Yeah, Brittany, Giancarlo, Jabari, Val, distribution. Yes, distribution is what we are tackling. So remember that when we are distributing, what we're doing is making sure that everything from one parentheses or group here or term multiplies with everything from the other. That's the biggest goal here, making sure that we're doing this the appropriate way. So here we go. I'm going to make sure that I write the negative 4x cubed, and just for good measure, because I'm going to copy that right over there. So here we go. We're going to go ahead and do negative 4x cubed multiplied by 3x. So I'll write the 3x right there. And then we see that it's going to be also multiplied with that 7. Now be very careful here, everybody. Be very careful. When I have a negative number multiplied by a positive number, off the top of your head, what's that going to be? Is that going to be a positive or negative? Yeah, that's going to be negative. That's going to be negative. And so you see that it's already negative here. You have, this term, then you have minus 4x cubed times 7. A negative times a positive is going to end up negative. So you always want to really keep an eye out to make sure that your signs are good. Nothing worse than doing your best and then making that one little mistake that, blows everything up. So with that, here we are. Now let's go ahead and simplify and see if we need to combine like terms. Here we go. First, let's take care of business over here in purple. Everybody help me out. What's a negative times a positive? Because it's negative times positive, so what's that going to be overall? Yeah, that'll be negative, no problem. Then we're going to get into, let me just make sure that's a little finer. There we go. Next, we have 4 times 3, everybody. Because remember, when we are multiplying terms, we multiply those coefficients. Yeah, that's going to be 12. Perfect. Let's write that down. And then lastly, remember, we are multiplying. So we have x cubed multiplied by another x. How many total x's do we have multiplied if we think about it that way? Yeah, that's 4 of them. And just as a gentle reminder to help us continue to reinforce what we're learning, remember, x cubed, that's x times x times x. If we're multiplying by another x, well, we'll just multiply by another x. But instead of writing it out 4 times, remember, the easier way is just to write x to the power of 4. That's the easier way to write it, because there's no way that we would expect ourselves to write all the number of x's that we have. No. That's the reason why, everybody. Again, I always want to reinforce this because it's so important. Those little things, way too important. So with that, let's turn our attention over. Shout out to Maggie, who understands it now, right on. So up next here, we know that we're going to have a negative in front. So let's go ahead and just put the minus, no problem. And now let's worry about, again, one thing at a time. I focus on the numbers, then I focus on the variables. Everybody, 4 times 7. Denise, appreciate it. That's 28. Right on. And then we have ourselves, well, nothing with the 7. So what do we do with that x cubed? Exactly. We just keep it. We keep it and we bring it down and we keep the party going. So that's going to be x cubed. And there we go. Now, everybody, should we be combining the like terms here? Should we be combining the 12x to the 4th and the 28x cubed? No. So you're telling me we're done? Okay, explain it to me. Why can't we combine these terms? I see that we have the same variable. What are y'all going to tell me? Yeah, they don't have the same exponent as well. Exactly. You know how I like to do things? I like to be repetitious. Repetition is so important here. But yeah, although they both are x's, to add or subtract terms, we also need the same exponent. We also need the same exponent. Exactly. So with that, we are done. That's the final answer. Negative 12x to the power of 4 minus 28x to the power of 3. And there we go. So boom, there's your answer. The correct answer here will fall under answer choice A. Negative 12x to the 4th minus 28x cubed. So one question here from Alex before we move forward. Alex asks, so what do we do if they did have the same exponent? So theoretically, again, in theory, if this was a 4 instead of a 3, well, then you would do negative 12 minus 28, and that would be negative 40x to the power of 4. Again, if they were the same exponent. If they were, but they are not, so we just leave it as is. But if we did have the same exponent, oh buddy, yes we would combine those two terms. So with that, I want to give y'all an opportunity to keep trying. Are y'all ready for some more practice? All right, perfect. Let's go ahead and get into it here. Let's keep the party going. So looking at our next example, we are going to be multiplying the following expressions here. We are going to be multiplying 2x to the power of 4. And we're multiplying that by 5x minus 3. Okay, so let's go ahead and do what we've been doing this entire time. Notice that we are multiplying this term here by this parentheses here. The distributive property, how I've been talking to you guys this entire time, is going to follow the rule. Make sure everything from one parentheses multiplies with everything from the other. So the 2x to the 4th is going to multiply with the 5x. And it's also going to multiply with the minus 3. So just again, take it one step at a time and we'll be golden. So here we go. We have 2x to the power of 4 multiplied by that 5x. Then we have the minus right there. So everybody, quick question. When we start writing the second half here, what sign are we going to write? We have a positive 2x to the 4th multiplied by a negative 3. What sign are we writing? Correct, minus. We are going to write the minus because a positive times a negative is a negative. And then from there, we have 2x to the power of 4 multiplied by that 3. Notice I'm not going to write negative 3 because I already thought about the sign right here. So be very careful about that. But nonetheless, we have the 3 there at the end. So now we'll move forward and perform our operation. So what we'll have here is 2x to the power of 4 multiplied by 5x. When we're multiplying, I simply multiply the coefficients first. 2 times 5, that's going to give us 10. And then we have x to the power of 4 multiplied by another x. How many x's do we have being multiplied all together? Yeah, we have 5 x's multiplied together. I would not say 5x. That's something very different. 5x and x to the power of 5, two completely different things. So with that, this is going to be, again, x to the power of 5. Now, with that up next, we are going to be taking a look at the right side here. So here we are going to have 2x to the power of 4 multiplied by 3. So here again, we'll take those regular coefficients. 2 times 3, that's going to give us 6. And since there's nothing over here, we're just going to drop that x to the power of 4 down, and we're good. And that's it. And we're done. The correct answer here, my party people, will be answer choice C. 10x to the power of 5 minus 6x to the power of 4. So with that said, are we ready to try yet another problem out? Perhaps a different one, a different type. Who here is getting a little antsy thinking that, man, I came into this class really worried, but now I'm itching for some problems here. I'm itching to kick some butt. Okay, cool, sounds good. No problem at all. Let's take a look at this next one. All right, and let's give this next example a shot. So clearly, I don't think it goes, without saying, we're looking at something different, right? We're looking at something different because what we've been used to up to this point has been, hey, there's only been one term, not two. There's only been one term in front of that parentheses. But now when we take a look at this, everybody, is it okay or is it fair to say that throwing in two terms times two terms, that's a little weird. That's a little weird. That's a little different. That's a little unfamiliar relative to what we've been doing. Is that fair to say so far? Yeah, I would agree too. So with that, here's the thing though. We're not doing anything different. We're going to follow the same exact process. Everybody help me out. What was that main note that we took? That main note that we took before getting into this specific problem. Specifically, it had to do with the distributive property. If you can write it down before I'm done copying and pasting this into the proper page that we're on, bonus points. So coming back over here, booyah right there. Yeah, distribution. We are going to make sure that everything from one parentheses multiplies with everything from the other. That is what we are going to make sure we do. Now, really quick question though. Has anybody here ever heard of the method for foiling? F-O-I-L? Has anybody, or excuse me, this is the right problem. I got y'all, my bad. Went one slide over. There it is. But have y'all heard of FOIL? It's an acronym that stands for first, outside, inside, last. You could be a math extraordinaire, right? Yeah, so check this out. This is the problem that I have with learning. This is the problem that I have with memorizing and thinking that you've learned something. So let me show you the FOIL method, and then I'm going to show you the same thing we've been doing right over here and how it's going to help us. Watch. Here we go. So let's go ahead and do x plus 5, x minus 8. Okay, cool. So let me show you the quote FOIL method. Let me zoom on in a little bit so I can get more room. Here we go. So I'm going to write it in different letters. I'm going to write FOL. Foil, okay? Foil. This is what you have to remember. But here's the problem with FOIL. It only works when it's 2 by 2. This idea here works for any size. It could be 1 times 2, 1 times 3, 2 times 2, 2 times 3. This always works, and I'll prove it to you right now. First, let me show you what FOIL looks like. So F stands for first. And most people will go ahead and take the first one here, those two multiply together. So I'll do that. Everybody, x times x is what we're going to write. Next, we have O, which stands for outside. That means the outer terms, the x and the 8, those are being multiplied together. Again, the outside terms. So what that's going to give us is a negative 8 times x. So that'll be negative 8 times x. Next, everybody, what does the I stand for in FOIL? The I ends up standing for inside or inner. I'll go ahead and write inside. Either way is fine. And so we have the inside terms, the ones that are closer to each other on the inside, 5 times x. So that'll be 5x. And then we have last, or L, and that's going to be the 5 multiplied by the negative 8. So we'll have minus and a plus, a negative times a positive. That's going to end up being a negative or a minus operation. And then we have 5 times 8. So that's what FOIL stands for. It only works when you have a 2 by 2, but it does work. First, outside, inside, last. Those are the term pairs that you multiply together. And then once you're there, then you actually go ahead and clean things up, combine like terms, and do your thing. So even if you're confused, let's go ahead and finish up here. And I'm going to show you doing it again with the distributive property, how much more sense it can make. I got you. So let's go ahead and get to this. Everybody, x times x, what's that going to simplify to? Yep, that's going to be x squared. Now let's go ahead and take it over to negative 8 times x. That'll just be minus 8x. Then we have 5 times x. That's just going to be 5x. Then we have minus, so minus. Everybody, what's 5 times 8 going to be? Yep, that's going to end up being 40. Keep that negative there. Keep that negative. But here we are. X squared minus 8x plus 5x minus 40. There's one more thing that we have to do here, though. Something we haven't really done yet when it comes to multiplying and distribution. What was that thing that we could potentially have to do, everybody? It starts with a C. It's a couple of words. Yeah, combine like terms. This is the part where we combine like terms. And I'm going to go ahead and highlight this in a different color. Let me grab, let's go ahead and say brown. Let me go ahead and combine these two right here. So let me write that down. Combine like terms. Everybody, one more time, pop quiz. What makes these like terms? Not only do they have the same letter, but they also have the same, they also have the same exponent. That's why I didn't include the x squared. I only include the negative 8x and the positive 5x because we have the same variable, x, and the same exponent, 1, on those terms. So with that, let's combine here, everybody. We are doing a minus 8 plus 5. If you understand your negatives, what's that going to be? If I have a negative 8 plus 5, that's going to end up at what? Yeah, a negative 8 plus 5. Remember, that's the same thing as 8 minus 5, but then just make the answer negative. Again, 8 minus 5 is 3, so negative 8 plus 5, if you go the opposite way, that's negative 3. And then you can just write the minus 40 where it was, but there we go. Let me just highlight all this so you can see it. We combined our like terms, and we're done. That's it. Let me go ahead and just move this a little lower and show you our final answer here of x squared minus 3x minus 40, which, everybody, the correct answer listed is which choice? Yep, that's going to be B. That is answer choice B, and that's correct. Boom, right there. Now, who here would like to see me do the same exact problem, but with a simple strategy? Make sure everything from one parentheses multiplies with everything from the other. Who would like to see it in the easy way? Cool, sounds good. Let's go ahead and do it. First, let me go ahead and duplicate this page right over here. Duplicate. Perfect. Okay, so I have a replica going, so I can erase the FOIL. Goodbye to you. And then let's go ahead and take this out of frame, take that out of frame. Let me just erase everything slowly but surely, and then I'll take all that. Perfect. So let's go ahead and just go through this idea. If you're sitting at home and you're not here live, say this out loud with me. Read it with me. Distributive property. Make sure that everything from one parentheses multiplies with everything from the other. Let me show you how that looks. Let's zoom on in and let me show you. So I'm going to begin with this x over here. I'm going to make sure that this x multiplies with this x, x times x. And I'm also going to make sure that that same x multiplies with the negative 8. So that'll be minus 8 times x. Before I continue, everybody, let me know in the chat box here, do you see how I've completed this x? I've completed multiplying this x with both of the terms that I saw in the other parentheses. Do you see that I've done that? I did, this x was multiplied and the negative 8 was also multiplied. It was 2 multiplications and I've done them both. Are we ready to continue with making sure that the 5 multiplies with both of those terms as well? Are you ready for that now? Cool. Again, that's all we're following. That's the only rule we're following. Make sure everything from one parentheses multiplies with everything from the other. This x needed to multiply with the other x. Boom. Also needed to make sure that the x multiplied with the negative 8. Boom. Now I'll continue. Now I'm going to make sure that the 5 multiplies with everything from the parentheses multiplied by the x. So that's plus 5x. Then multiply the 5 with the negative 8. So that'll be 5 times negative 8. Again, that's all it takes. As long as you remember the rule, notice how we just did the exact same multiplication without having to look goofy and write this down. And on top of that, it just takes less time as you build more confidence with this. So when we take a look at where we currently are, here we go. Here we go. Everybody, x times x, list it out loud. Go ahead. X times x gives me x to the power of 2, just like we saw before. Doesn't change anything. That's right. Then we have negative 8 times x. That's minus 8x. We continue from there. 5 times x, that's 5x. And then we have the 5 times the negative 8. Everybody, 5 times negative 8. What's that going to give us? Correct, negative 40, just like we saw before. So notice how we ended up at the same exact spot with less to write down. And now all we have to do is combine those like terms just like we did before, and we're set. Negative 8x plus 5x. Everybody, what's that gonna be? Just like we saw before. Yeah, negative 3x. That's right. So we have x squared minus 3x minus 40. And we can see that we can get the same exact correct answer with a different strategy. But remember that this strategy works for all polynomial distributions. It works for all of them, not just this hyper-specific like FOIL. Because I promise you, if all you know how to do is FOIL, the moment that we throw a problem your way that looks like this, 2x plus 3 multiplied by x squared minus 2x minus 7, the moment I throw 3 terms your way, you're not going to have any idea what to do. And that's why knowing the general main idea always trumps any other hack or secret. I hope you know what I'm getting at with that. So remember, everybody, it's better to understand than to memorize, and this is a perfect example of where understanding can give you the advantage. My party people, are we ready to try another one out? With the strategy that you like the most. Good. I like the attitude. Let's go ahead here and set ourselves up for that, and let's get it going. And let's keep taking it forward, my party people. So before we get started on actually solving this problem with the technique that we know, is it clear to you personally, again, give me an honest yes or no, is it clear to you personally that you can't run away from negative numbers? They're going to appear at some point or another. We have got to make sure that we're ready for them on this test. Is that an agreeable statement? Perfect. I'm glad that we understand that. And, I say this all the time, and I want to make sure that anybody who's here for the first time hears this. But remember that even though it's not your fault that you have anxiety towards negative numbers, even though it's not your fault that you're not as good as you want to be, it's your responsibility. It is your responsibility to understand where you're at, take the steps needed to get better. That way, as I like to say it, that way you don't get got on the actual test. Again, it's not your fault, but it is absolutely your responsibility. So let's go ahead and get into it here. We are going to be distributing x plus 4, and we're distributing that against x minus 6. So we have these two expressions multiplied together. But just like we said with our distributive property, we're going to make sure that everything from one parentheses multiplies with everything from the other, just like that. So with that, let's go ahead and do it one at a time. x times x, that's going to give us x squared. Then I'm going to use a different color here. When I make sure that the x multiplies with the negative 6, that'll end up being negative 6 times x, which is negative 6x. Then up next, we're going to make sure that the 4 multiplies with both of these. So here we're going to have 4 times x, which will be a positive or plus 4x. And then lastly, we have a positive 4 times a negative 6. Everybody, what'll be the sign of that? Will it be plus or minus on the operation there? Yeah, that's going to be a minus. And so we have 4 times 6, which is 24. And there we go. We've done the first part successfully. Now there's the next step that we have to do, which is going to be the combining like terms part. So let me go ahead and grab a different color here, and let's grab brown. Perfect. So now we are going to combine like terms. Yeah, right there. So let's go ahead and do that, everybody. The like terms that we are going to be combining are going to be right here. The terms that have the same variable and the same exponent, these are the terms right here. These two only. They both have an x and the only x to the first power. So with that x squared that's written in the front, it stays the same. That minus 24 at the end, it stays the same. Now we're just going to be focused on negative 6x plus 4x. And remember, if you have a negative plus a positive, you can just do the opposite. Just do 6 minus 4, but keep the answer negative. Remember, 6 minus 4 is 2. But negative 6 plus 4, if you go the opposite way, it's still 2, but it's a negative 2x. My party people, does that help? Does that make a little bit of sense? And does the overall answer here make sense to you? Let's put that all together. X squared minus 2x minus 24. And the correct answer here will end up being answer choice D. Good, I'm glad it's making more sense. I'm glad. Again, it takes time, right? It takes time, but when you trust that process, when you give yourself that patience and grace, again, positive results always come. It's just a matter of when, not if. It's just a matter of when. So with that, again, yeah, exactly. You can't assume how long it's going to take anybody, including yourself, to learn something. That's pretty pompous. So let's go ahead. We're going to have time to get let's get 2 more problems in here. And then here's what I'm going to show you to get you excited for the class coming up tomorrow. So when it comes to tomorrow's class, we're going to be looking at things like, hey, what if we had 1 by 3 terms? What if we had 2 by 3 terms? We're going to get into those tougher ones for sure. So let me go ahead and actually just skedaddle over to this next one. Let's make it slightly tougher. Let's see how we can handle this one here. So give it a shot, my party people, and we'll be back in a moment to give it a go. All right, so let's give this next one a shot. This one's obviously a little more complicated. What we're trying to do here is we're trying to simplify this expression by multiplying these 2 binomials. Again, a binomial is just an expression with 2 terms. So with that, my party people, let's go ahead and understand this, everybody. Pop quiz, what is the operation that we're going to be using when it comes to distribution? When we distribute everything from with this parentheses to everything from the other, what operation are we using again? Yeah, multiplication. Okay, cool. So with that said, everybody, we are going to get to the first term by multiplying the first 2 terms here, right? Because if you look at x squared, that means that you have to multiply x and x together. Quick question, everybody. Quick question. When you multiply 3 times 2, what do you have to have in front of that x squared? What do we have to have? When you multiply the 3 times 2, yeah, that's going to be a 6. Which one of these isn't a 6? Right there. A, already out of the picture. Already out. Here's another question, everybody. How do we get to that last number that's just a regular number without the variables? Well, that's when we multiply the constant terms, the ones that don't have variables on them. That's how you're going to get the number without a variable. So everybody, what is positive 5 times a negative 4? What's that going to be? Oh, negative 20? Oh, which one of these is not negative 20? Oh, B. Look at that. So even before you get started, if you knew how this concept works, look at the advantage you have. Even if you're running low on time, you got a 50-50 shot right away. Anybody here feel like that would be advantageous, especially if we find ourselves running out of time frequently on the test? Yeah. So again, we have to find those advantages where we can. Always, always, always. That's one of those test-taking tips that I can provide. So with that, let's go ahead and actually perform this operation here. Let's see what the correct answer is, and let's keep moving forward. So we have 3x plus 5, and then we have 2x minus 4. From here, my friends, we're going to go ahead and do what we said. We're going to make sure that everything from one parentheses multiplies with everything from the other. 3x times 2x. Then we have to make sure that 3x also multiplies with that minus 4. A positive times a negative, that's a negative. Negative 4 times 3x. Then I'll continue forward by making sure that the 5 multiplies with the 2x. So that'll be plus 5 times 2x. And then lastly, we'll have 5 multiplied by negative 4. And like we said just now, that'll be negative 20. So now that we're here, everybody, now that we're here, again, making sure that everything from one parentheses multiplied with everything from the other. Now it's just cleanup time and combining like terms. That's all it is. So let's get to it. Here we go. First things first, 3x times 2x. 3 times 2 is 6. And when we multiply these x's together, we will go ahead and add those exponents. X to the power of 2. Remember, there's a 1 on top, always. Next, we're going to have negative 4 multiplied by 3x. When we take a look at this here, we are going to have a minus in front. 4 times 3, that'll be 12, and then we just bring the x along. Next, we have the 5 times 2x, and that'll end up being 10x. And then lastly, we have the minus 20 that we just drag along at the end. So with that, the last step that we need to take here, like we've been saying, is combining like terms. CLT, looks like a BLT. Yes, I'm kind of hungry, but that will be combine like terms. So with that, we are going to bring these together. Booyah. And so remember, we have minus 12x plus 10x. So really what we're thinking of is negative 12 plus 10. Again, you can flip the signage as 12 minus 10, that's 2, but we're going the opposite way. It's negative 12 plus 10. So that's the same as doing 10 minus 12, which is again, negative 2x. So boom, right there. And there we have our final answer. Nice and easy. The correct answer here is C. 6x squared minus 2x minus 20. So who here feels like that patience and practice has been rewarded? How do we feel about this at the end?